So now we're joining Jim Bacon with why radio and weather go together. And most of us accept that there's a strong link between radio and weather conditions. But what is the real relationship? Sometimes a little more understanding of the weather can help us get more from our hobby. And who better to give us the lowdown than a professional meteorologist and long-time radio amateur. So it's welcome to the RSGB convention to Jim Bacon, G3YLA. Hello, Jim.
Hello, David. Nice to be with you.
It's good to see you. And this is your second outing today. You were on the other side earlier, weren't you?
Yes, I'm just going to try and remember not to do exactly everything I did this morning. But this is kind of like a revision exercise, but it's going to be in a more user-friendly way. And I also want to perhaps later on attempt to go live into one of these propagation programs that we use to try and look for features that you might be trying to relate to the weather on the air. So tuning across the bands, sometimes just seeing what the bands look like is a very good way of relating propagation theory with practice.
Absolutely. Well, we're looking forward to it. And this is just a good moment to tell everybody at home now that you're watching this. It is live. And any questions that you've got for Jim or comments, please ask them as soon as you can on the YouTube chat, because we don't have very long at the end of Jim's talk for questions. So just enter them as you go along and we'll either read them to Jim during the talk or straight afterwards. But now back to Jim. Let's find out how weather and radio go together.
Thanks, David. Well, good afternoon, everybody. And I'm sorry to burden you with two lots of weather. I always used to say you never have too much weather. And for a weather person, you never actually have a day off, because every time you walk out the back door, there's weather out there. And there's been quite a bit of weather about today, some heavy showers, some thunderstorms, things like that going on. So in a weatherman's world, that sort of stuff is quite exciting. In an amateur radio world, it kind of has its ups and downs. So it's not uniformly a good thing necessarily. One person's good weather is another person's disappointing weather. So we're going to cover a few of these sorts of things. And along the way, I want to kind of address this in a form that's accessible to folk who maybe in the last year during lockdown have started to experience amateur radio for the first time. You're maybe thinking about why the bands behave as they do, why certain bands open at certain times, and none of that is magic. In the old days, when you got on the air, you had quite a prolonged period as an SWL, and you learnt to read how the bands were behaving. So you understood propagation perhaps a little bit more than you do these days as a modern amateur, because there's a trend towards people starting off on the VHF bands as opposed to HF. Not uniformly true, but it does tend to happen quite a bit. And therefore we're missing that sort of library of information that can help you make more of a hobby. And it is a hobby, but it's also a hobby that benefits from a bit of extra knowledge. So I want to try and steer you into that bit that makes it fun, and hopefully we'll be able to get you enthused to try some other parts of amateur radio. And incidentally, best wishes to Pete, and hope he's fit and well soon and be joining the RSGB at 8 sessions, because that was a talk that I was looking forward to as well. So the only disappointment now is to admit, as I did this morning, that I missed the breakfasts from the in-person conventions. Those were always a high point. And also I notice I'm missing a talk about CW as well. So being a CW person, I might mention that a couple of times during the course of this, but it's not mandatory. But if you do get a chance early in your careers, have a think about putting CW on the list as well. Okay. So, weather is your friend. Well, of course it is. It can be a good friend. Areas of high pressure, and you get fine weather, sunny weather, skies like in that picture there. That was an old 9-element timer on a stick with half an element broken off and generally on its last legs. A weather station in the background, and a neighbour with an aerial in the background beyond that. And so several things that we have to get used to in the modern amateur world, and some of those things are to do with propagation and what happens to us as we tune across the bands. Some of those things are actually to do with the environment that we're faced with, you know, whether it's produced by the weather or whether it's produced because you happen to operate in an area where there are lots of strong signals on a band that you want to be on. They're all things that you can work around, and just by knowing perhaps another band that might be open, understanding how they work, it's possible to do a bit more with it. Anyway, let's have a look at some of these other elements on here that, well, good. Thunderstorms, are they your friends? Well, they can be. If, for example, you worked on the gigahertz bands, and some of you will probably have read John G4BAO's column in Radcom. Gigahertz bands, very susceptible to rain scatter. Fascinating mode to look at. The whole reason we see rainfall radar now as part of our forecast on television is because it's such a good way of getting a signal reflected or scattered back from raindrops in clouds. Jet streams, well, we didn't hear much about those until the last 20 years or so. But when I started in the hobby, nobody was talking about jet streams in the context of amateur radio. But now we're talking about it both in terms of weather and how it drives our weather patterns, but also in terms of some of the propagation modes as well. Mountain waves, they sound interesting. We might have a look at those as well. So lots of stuff that we can take advantage of. So I'm classing those as potentially good things. So what could possibly go wrong? That is a picture of the field at the back of David's location, David, who's running this session. The Norfolk Radio Club has this, we have a field day, HFCW field day in the back field there. And this is a picture shortly before we tried to zap Roger with lightning one afternoon. And that's a very severe thunderstorm behind there. It doesn't look quite as dramatic as some. But lightning is not a good friend of amateur radio operators. You need to have your wits about you with things like that. And you do need to be aware of forecasts and not only what the forecast is, but actually think about, it's not just, as we say in Norfolk, looking back over world's mothers. And I'm sure you think that in other parts of the country as well. It's quite a common phrase. But what you've got to think about is not that it's black over there or over there, but you've got to think about which way is it going. And is the storm coming towards you, and so on. And lightning can take place quite a distance away from the center of the storm, but it's important to be aware of it. Loads of apps online and on mobile phones that you can go to for seeing where these things are. So there's no excuse for being caught out, but you do need to have a think about what is good practice in terms of operating a station during severe weather like that. Not many of us have to deal with snow on field days, although some of us probably feel that it's on occasions been cold enough. I think the point about this is if you're one of the fine body of folk who go up the top of mountains to do these SOTA events, I just love chasing those stations. And you get some incredibly fit and agile people take whole stations, albeit fairly small ones, but they're working with low power up to the top of mountains tops and operate. And sometimes the difference can be quite significant between the valley at the bottom of the hill and when you go up to the top. The difference between the car park at the bottom of Skiddaw and the top is something like 9 or 10 degrees if you go to the Lake District. So you might be dressed for a coolish day at the wrong time of the year down at sea level and find that you're looking at temperatures well below freezing on the top, and also with a strong wind, so the wind chill is not good either. So weather can do nasty things, and ice, of course. Well, snow and ice have a similar effect with feeders. They can cause shorts. They can cause one of the things is a very slow ingress of water as either snow or ice melts. Normally, when rain falls on an antenna outside, the rain will drop, will hit the wire, it'll spread out along the wire, wind will blow it and it'll flick off, and the wind will dry the wire pretty quickly. But where you've got snow building up on the surface, even on a doublet centerpiece or a dipole centerpiece or so on, a chunk of snow and ice on the top there can sit there for a long while and just melt very, very slowly. So it gives plenty of time for the water to run down the feeder. So you do need to pay attention to your feeders. Also, it's quite heavy. There's many pictures of very fine looking quads from the Midwest in the States that have been afflicted by ice loading and so on, and the wires have all collapsed. So weather can go horribly wrong. obviously weather is something you think about at home, but it's also something which you have to deal with when you go out portable. Top left is one of our popular events. We're not doing these things nowadays, of course, but the picnic that the club runs in the summer up on the cliff tops near Cromer at West Runcton. We have a nice little portable session there, QRP. It was a cloudy day that day, but just along the coast, we also have our own version of Summits on the Air. Your last speaker is in the top right-hand picture, and there he sits on the top of Beeston Bump. We slogged our way up there.
Do you think you want double money, Jim?
I beg your pardon?
Do you think you want double appearance money?
I think he will. You'll have to pay him twice for this, because he crops up later on as well, actually. I've just realised. Anyway, the point is, it is important if you're going out, say, for a long trip like this, to be aware of weather conditions, because it's a long way back down to the car park. Field day I've mentioned, and various clouds like the one in the bottom centre, thunderstorms and so on. But look at how I've included the one with the snow on it, just to show you how wet, sticky snow can accumulate on a centerpiece of an antenna. And that's just an antenna hung from a bedroom window, a 20-meter dipole. But just look at how well the snow settles on that. So if you had any imperfections in your sealing of the coax, that water would melt down and cause a mess in that. So you do have to think about these things. Incidentally, just immediately to the left of that loop of coax, the choke, you'll see what looks like the end of a VHF array, and that was the tonner that's on the picture just to the left after the wind blew it down one day, and it's sort of unceremonially propped up against the garage. Anyway, can't think why I put the one on the right in, but that's in there for some reason or other. So let's see what else we can say about it. You've got to try. It's all very well, we come on and do these talks and tell people you've got to learn this, you've got to learn that, but sometimes just a little bit of learning can make a big difference. So for example, if you're not familiar with how weather charts work, how high pressures look on a weather chart, what low pressure looks like, the bits that might bring you rain, those things are really important messages, and it's a good sort of symbolic shorthand, if you like. So big features like highs and lows tend to control where everything else goes. And highs can be obviously quite good for tropo. We've got used to hearing about that in the GB2RS. But also you need to be aware that lows can bring rain scatter, but also unsettled weather in a different way. They can bring stronger winds. Notice the high pressure, if I move the old mouse about here, just to the north of Scotland. There are big gaps between the isobars here, so the winds are quite light. But near the low, the isobars are very close together, so very strong winds. So if you get, I was going to say, if you get wind of bad weather coming your way, this is the sort of thing that it brings. And that's why every now and again, you do need to think about antennas. In extremis, you may have to even lower the masts if you've got one and just ride the storm out. But get used to looking at these and interpreting them, and you will save yourself a lot of unnecessary surprises. Field day. This is the field, the same field, but on a quieter day when things were less hostile. And this is the evening, just getting ready for the nighttime session. So several things that I remember feeling at the time were you can have a night like this, going into a night like this, and the LF band's starting to come alive. This is mid-evening, 9 o'clock, 10 o'clock time, and you're hearing some really loud static on top band and 80. And yet clear skies. So bear in mind that static from thunderstorms can travel long distances. So you'll be picking up thunderstorms over France or for example, Spain or somewhere a long, long way away. So once again, you need to either look to satellite pictures or various radar sites to see where the nearest storms are. You can actually see lightning at night from miles away. I mean, and I really do mean miles away. In East Anglia here, on the eastern side of the country, in the autumn, winter, early part of the winter, you get some very big thundery showers rolling down the North Sea on a northwesterly wind. And they will often produce thunder and lightning And what happens is at night you can see lightning in the sky and you're not quite sure where it came from. And I've been able to copy that, if you like, visually in East Anglia when the storms have been over Denmark. So you can see lightning a long way away at night, but also you can hear the static from even farther away. So what else can you glean from this? Well, clear skies at night means that the ground radiates heat away to space. The ground gets cold, it gets damp, dew forms. So a good policy, I'm sure many of you who do NFDs will have done this for many years, but if you are thinking of going out for the first time and trying it, absolutely to be recommended. Brilliant fun, especially the CW NFDs, but any of them are great fun, just getting out there and having a bit of a mission outside. But bear in mind, the ground does get cold and it gets damp. So old wooden pallets, make a great flooring just to keep your feet off the ground. The other thing that can happen, a particular set of conditions can bring you some good tropo conditions by dawn, by the end of the night. So if, for example, in the first week in July, you're on a VHF NFD weekend, you'll often find tropo conditions tend to pick up and improve as you go into the evening and overnight. And you're just getting into a run of good DX into France and Germany on 2 meters, and you can smell the bacon and egg cooking in the frying pan outside the tent, and you think, well, just go and have some breakfast. Don't. Work the DX until the lift goes, because these nighttime tropo periods that happen on NFD weekend in high summer are tending to be just during that nighttime dawn period. And as soon as the sun has been up for a little while, it'll evaporate away and you'll lose it. So have a late breakfast and just get the points in the bag first. An obvious thing, but a lot of people I've seen have fallen foul of that. Get hold of a forecast, find out which way the wind is going to blow, and make sure you don't put your door into the wind, because rain will find a way of getting in there. You can trust me on that one. Okay, there he is again. So that's double money for Steve. This is something which catches so many people out. If you're going out portable and you're going out in high summer, then for heaven's sake, remember to take your sunscreen. The one thing we have up on the North Norfolk coast is that the sea at this time of at the early summer, you're talking about Easter into Whitsun into early June, you tend to think, oh, there's a cool breeze coming in off the sea. It's going to be fine. I can't possibly get sunburned. You can. It's not to do with how warm the air is. It's to do with how strong the sun is. So do remember to take your sun cream. Luckily, Steve had had a large bottle with him. Right. Okay. This is a very bad thing. This is a cumulonimbus cloud, and the classic shape is such that you get this anvil look at the top of it. And what happens is, in here, there's rising air in the center of a thundercloud, and the air may be going up these thermal air currents that take it up. Something like 100 miles an hour in an extreme, this won't be one of those, but say 60 miles an hour, very common. And when it reaches a stable layer at the top of the atmosphere up here, it tends to spread out and form this anvil of ice crystal cirrus cloud. But that's a classic sign of a thundercloud. Now, they can do several things to you. Obviously, you don't want to mix it with the thunder and, well, the lightning. Thunder won't harm you, but the lightning certainly could. But be aware that they can bring some incredibly gusty winds as well. And possibly, if you're camping, some damaging hail. Tents don't do very well in a hailstorm. So those things are good to follow on rainfall radars and those mobile phone apps, because they carry a whole bunch of bad things in a small package, and although they might not last long, they certainly pack a punch when they're with you. So get used to tracking those and making sure you're either not in the place where they're going to be, or if you are and you can't avoid it, then make sure you batten down the hatches temporarily. Okay, so we're just going to do a little bit of a primer about tropo. Now, this is some of the stuff that we did in the other stream this morning, but I'm not going to go into a great deal of detail, except to say for these next, what are we now? We're just into the middle bit of October. The autumn months are typically very good for tropo. So as we head into this first half of winter, you can get these, these nights of mists and mellow fruitfulness, the bonfire night smoke that goes up and then goes out horizontally underneath the temperature. All good tropo stuff. So we want to find out how to do that. So if you only just got your license and you're limited to the amount of power you can use, don't worry. Low power isn't a problem for Tropo, and certainly not a problem for CW. Anyway, things that affect Tropo are things that affect the refractive index of the air. Now, by that, I mean the refractive index is what changes how an electromagnetic wave, if you like, propagates through a medium. So if that medium changes, the refractive index chances are it's changing as well. So the classic example is where you see a pencil into the beaker of water, and it appears to bend where you move from air to water. So that's the sort of thing we're talking about, but with VHF radio waves. So it can bend it if the refractive index changes. But it turns out that these three things on the slide here, temperature, pressure, and moisture, are the three things that appear in the equation for the refractive index. Now, pressure doesn't matter too much in the sense that at the place where we're looking in the region of an inversion, temperature inversion, pressure is pretty much the same just above or just below. But the changes in the temperature and moisture as you go across that inversion are absolutely crucial. So what we do, and this isn't me, but it's about the era when I started in meteorology in the late 60s. Here you can see a radiosonde balloon coming out of its shed, and there's a long piece of cable, and there's the radiosonde package of instruments, which are measuring those three things that I mentioned. Now the modern, that's an old one, obviously, but the modern one is about the size of a packet of 20 cigarettes, if anybody still remembers those or still uses them. So this is a, I think they're currently up around 400 odd megs or some such place. They used to be on 27 megs or somewhere near there, which was quite exciting at times for some of the figures that came back. So that gets launched, this goes up, the balloon goes up until it expands against the lower pressure as it goes up, then eventually it bursts and the package comes down. But all the measurements have been taken as the thing goes up. So what does it measure? Well, it measures these two things, these two curves here. So you've got temperature and you've got dew point, which is a measure of how moist the air is. So dry air is when they're a long way apart, and moist air is when the two lines come together. And there you could have cloud, or you could have, if it was at the surface, fog. And these are graphs which we call tephigrams. Now, they're not things that you'll see in general usage. They're meteorologists' sort of charts for plotting these things. They have a lot of other useful properties as well. So we're not going to go into that. But it does allow you to say, OK, we've got some inversions. And what I mean by an inversion is where the temperature decrease with height changes and either starts to rise or remains constant. That inverts or changes the normal falling off of temperature with height. So you might say, why is that going to happen then? We're going nearer the sun. Well, it's not that. The heat in the air comes from the ground below. So the ground is actually being heated by the sun. That warms the air, and eventually thermals will rise up and transport that heat upwards. Now eventually, it will go, if nothing else happened, if there was no moisture around, it would follow one of these lines going diagonally upwards like that. But usually there's other things going on to make it different. And one of the things going on to make it different is that high pressure areas, and this is why it's so important to look at where highs are, forces the air to sink over a large area, thousands of square kilometers. So the air is sinking, and that produces an inversion where the temperature here appears to be higher than it is here. So you get this temperature change, and that temperature change is a very stable thing. So what it actually does is it acts as a vertical lid, if you like, on rising motion. And the same thing can happen at night when the temperature at the surface here gradually decreases as the air cools. Remember our pictures of NFD with the clear skies? This is what your temperature will do at the surface on that NFD night. It will start off here and it will gradually cool, but because the air just above the ground is not touching the ground, it isn't cooling as much because air is a good insulator. That's why a pallet makes such a good platform to sit on, because there's an air gap between you and the ground. So here you have this nocturnal nighttime cooling inversion, and the surface temperature will be lower than the air temperature just above it. So the end result is we can have inversions just about wherever you like. They can form up here due to the high pressure, and you might see smoke going straight up and then off it goes at right angles. Could be layers of cloud. You could find cold air draining into a valley at night, and you'll get mist and fog, and then you'll get surface inversion. All sorts of places to see them. So this one on the left was a nighttime cooling inversion near the surface, and when I say near the surface, it's the bottom sort of 100 odd feet or so, 200 feet. And there you can see this bit is a layer of smoke from a chimney, house fire just drifting out through the misty and frosty morning. And here you can see the picture we looked at this morning of a frost and on the fields here, but also fog in the valley. So there's many good ways of finding out where the inversions are. And it can happen above the ground as well. Here's an inversion. These are clouds trapped under the inversion. Remember, we had that slide a little while ago. So things like this should make you think, perhaps there might be a bit of tropo. So the next question is to do with how do you take advantage of it? Well, you get on the VHF bands where tropo is more likely. We heard about sporadic E, and we'll talk about that a little bit later on. But tropo tends to work better on the higher frequencies. So 70 centimeters will have better tropo than 144 megahertz will, 2 meters. So the other thing that's really important to remember is that tropo events, when they happen, are quite long lasting. They happen for as long as the weather conditions apply. They're not very flighty, fleeting, brief things like sporadic E. So you've got bags of time. It's just a matter of deciding how to make the most use of it. So GM0 USI did, he had a cracking time because on 2 meters, he worked into southern France on the borders of the Pyrenees. And you can see this cross-section produced by Marcus Walden, G0IJZ. And he plotted the signal path and the effect of the atmosphere on that distance. And the bright red colours on the left are the low loss, and here we have loss in dBs coming along here, which is actually, quite high. When you get into the blues, it's extreme, 250 dBs or more. But the interesting thing is you can see how it picks up the inversion. So when you've got a good strong inversion present, you can see signals projecting over very long periods. And it's a propagation mode that basically is as long as the high pressure area gives you the right conditions. So you could, for example, use one of the many wonderful websites. So we've got two that I look at. There's probably others, but these are the two which most of us will be aware of. There's F5LEN, Pascal's website, and there's William Hepburn's website. And they both plot for different parts of the world. You select Europe and it comes up with a plot. And it's, I think, about 3 or 4 days ahead. So you can see when the computer models are expecting tropo conditions. So how's that happening? Well, what these do, they're both plugged into mathematical weather forecasting models. And in the lower layers of the atmosphere, you have the ability, and certainly some of the models, to get quite a high resolution, and they'll be very good at picking up, in some cases, the nighttime cooling inversion, but also the subsidence inversions, which I mentioned. But you're going to ask why these are perhaps slightly at the same time, but they look slightly different. And that's because they're based on different models. So weather models are not all the same. Some of them might have different distances between the data points, different number of vertical levels in them. I think this one's got 105 and this one's got 84. But it doesn't matter if they've both got lots of levels at the lower layers where these inversions are important. But they're both very good, and there'll be a terrific guide as to what's going on. So for this one, both models suggest that you would get good propagation from, say, Norfolk up the east coast past Caithness and Flamborough Head and all the way up to the east of Scotland, say Aberdeen, for example. Slightly different in how they treat what's going on in the Baltic, so not quite sure what's happening there, but that's a slight difference in how the models run. But it's something to get used to using. And if you're limited in power, then having low power and a new license does not preclude you from doing DXing on VHF. And if you play the right cards by looking at what the weather's doing, looking at some of these extra lifts, if you like, I mean crutches, if you like, to give you a new idea as to what to try next, then you'll do very well. And not just FM, the other modes are equally good, if not better. So sideband and particularly CW. Need to get a bit more CW on too. But have I mentioned CW yet?
I think you once or twice.
Did I? Okay, well, I'll stop now. So let's just sum up the Tropo bit. And the Tropo bit, this is your sort of slide to go home with in a way, because there are several things to read from a weather chart. So let's assume you've decided you're going to start to look at weather charts more seriously. Then look for areas of high pressure which are fairly substantial in size. So an old high, if it's been around for a while, it means it's got a marked inversion over a wide area. So DX distances along the edge of this are particularly profitable. So that would take you from northern France or southern England all the way across into Poland or the Baltic and so on. So a really good bit of DX on VHF. Just beware that the second point, if you do beam across the high, the center, as a high gets older, what happens over time is that main inversion gets nudged downwards and downwards and downwards. And eventually what happens, it reaches the surface. And when it reaches the surface, you haven't got this narrow layer of misty, foggy, cool air below the inversion. That's gone. It's all dry air. And no moisture is not a good thing for making a big change in refractive index. So the next thing you need to look for is waiting for the high to drift away. And we always used to talk in terms of high pressure, and yeah, that's great, pressure is really high, should be a good lift. And there perhaps isn't quite such a good lift as you expect. But then all of a sudden, it starts to pick up. And usually it's when the pressure starts to fall, the barometer starts to fall. And that's because as the highs, and typically in this country, they tend to move away to the east. As it goes away to the east, it allows moisture in under this low inversion. And that brings you back this big contrast. Moisture is by far and away the biggest contributor to that change in the refractive index. Way more important than changes in temperature. The changes in temperature are actually just good enough to trap the moisture. So that's how that works. What have we got here? Close to the low, strong winds destroy the inversion. Well, you all know how windy weather works, and you don't very often see inversion type conditions. Well, you don't see inversion type conditions then. Air from the southwest brings the surface moisture as the high fades away. We've done that bit. A new high you might see on a chart popping up, and sometimes they're fast, well, relatively fast moving. They're not these static things like this one, but they move along in between the lows. And then behind a weather front, you can sometimes score extra points in NFD if you see a front going across and decide to beam parallel to it just behind the front, because actually what happens in the upper atmosphere, a weather front, is going to behave a bit like what we've just been talking about, this sort of temperature inversion with a contrast of warm, dry air and cool, moist air against each other and so on. So you can get inversion conditions which can give you a temporary lift. Anyway, so that's Tropo. Then we're going to have a quick look at sporadic E. Now, this is one thing where I do really honestly think, as a new licensee with limited power, you should have no fear, because sporadic E will see you through the summer months. It's just a fantastic mode. People have variously said you could put a screwdriver in the back of the aerial socket. I don't recommend that at all. Martin Lynch has probably fallen off his chair now. But anyway, you can put a screwdriver in the back of the aerial socket and you can hear sporadic E. You can. They're terrifically strong signals. Single hop sporadic E is one of the more exciting things you'll work. So just imagine you're listening on, well, 6 meters, but even on 2 meters, this happens. You've got a quiet band, lots of background noise on 2 meters, say, and then all of a sudden it's full of Italian signals. And you just cannot understand how this can be. It can go from a flat band to Italian signals all over the place. Sounds like 20 meters, and it's sporadic E. Such low loss signals are just incredible. And then almost as soon as it happens, It's gone, because sporadic E is a very fleeting, flighty business. So you've got to get in there and work it quickly. CW, oh, sorry, I mentioned it again, but it is a very good mode for it. But particularly in latter years, FT8 has become a go-to mode for sporadic E as well. And that's a particularly good one to use as well, because you can get better, well, you get more openings, because it needs less of a reflection quality than you'd get with than you need for CW and SSB. Not much in it, but anyway. So new licensees with restricted power levels, don't worry about the summer months. You'll do very well on 10 meters. Is a great band for sporadic E. You can cut yourself well, I'll tell you what's a good thing to do. Make a slim jim out of ladder line, 450 ohm ladder line, and make a slim jim. There's loads of websites about where you can get the dimensions. Slim jim for 6 meters or a slim jim for 10 meters. You'll have a field day. It'd be fantastic. I think I worked about 45 countries on 6 meters using a slim jim with ladder line on one of these fiberglass poles. Just absolutely amazing things to do. Signals booming in. You know, you don't even need the radio switched on to hear them. It's that good. Anyway, so let's have a look. It's complicated, so I'm not going to do a lot about the complication bit, except to say the interest as a new licensee should be in when to listen. And when to listen depends upon the time of day, and it depends upon what the weather's doing. And this is where the weather comes into it, because it turns out that a lot of the things that determine where sporadic E happens are driven by things in the weather world. So, and it's all because those things then go on to make wind shear in the upper atmosphere. Now, there's a lot of misquotes about all of this. You do get wind shear in the lower atmosphere. Airfields, airports will have wind shear detectors. So when aircraft come into land, they can detect sudden changes of wind. And that's very important for aviation. But we're not talking about wind shear at ground level. We're not even talking about initially, well, we are. We'll talk about in a moment, wind shear, say where the jet stream is, but where sporadic E is, up there at 110 kilometers, 100 kilometers above the ground, there is wind shear. And by that we mean changes in wind direction. Now this kind of looks like what it is. It's either a crazy out of control rocket that's gone up and whooshed about and not knowing where it's going, or it's what happens to the vapor trail once it gets up into an area of the atmosphere where there's wind shear. And you can see some very classic signatures here for wind reversals of direction. Now, it doesn't need to be an exact opposite, but that directional change is really, really crucial to making sporadic E. And it's only very occasionally you get evidence that that's what it looks like up there. So this is a schematic of how you make sporadic E. It's basically the neutral winds up in the E region. If they're going in one direction at one height and in the other direction at another height just below it, they will either converge ionization into a thin, dense layer, or they'll separate it. So you'll get movement away and you'll get movement too. And sporadic E forms where they move together. And there's all sorts of other winds that get involved in this. So there's the neutral wind, there's tidal winds up there, which follow the sun around, which is why sporadic E tends to happen at certain times of the day, because as the world spins, then the sun's heating the air and it changes the winds up in those regions. But it's where that all interacts with stuff coming up from the weather bit down below that alters how these ions move. Ionization. This is what happens when meteors burn up in the upper atmosphere. So you've got meteor showers as being a crucial diary note in the sporadic E operator's calendar. And as a new licensee, you should be thinking about what the meteor shower dates are and book your holidays. It all happens because if you move a charged particle, which is what this ionization is, through a magnetic field, it will be deflected. And it's that deflection in the presence of the Earth's magnetic field that will actually cause the ionization to converge into a dense enough layer to reflect your signal back down again and give you a sporadic E event. they're quite narrow, as we heard from the talk this morning. And they are very flighty in the sense that they may not last long. On the higher frequencies, they may not give you the geometry for a particular station for very long. They can do in a big event, but on a typical event, they might not. There are other things to have in the back of your mind about sporadic E. Once it's formed, it will tend to decrease with height. So what you've got to do, if you assume that the higher it is, the geometry is such that you've got a longer path between the two ends, then you want to be in when the band is just started opening up. And as you go through the opening with time, that path will be less because the layer is lowering. Any road up. Thunderstorms, find out where they are. That's a good place to look for sporadic E, but not as good as looking for jet streams. And jet streams are by far and away the most important things to look out for. So here we can see jet streams. Well, we can't. We can see sporadic E and the satellite. I've just looked at the clock and frightened myself. Here we can see the cloud, but this is the only one that looks really interesting. Can you see these linear lines here? And this is where the main event was. But all of these, what's going on there? Jet streams are going on there. So if you had to follow one single thing, follow jet streams on a weather map and note where the meteors are. This is a very useful chart from, it's put on to me by John Worsnop, G4BAO, who does the gigahertz column in Radcom. And this is from a paper which looked at 2 years, 2011 and 12, of meteor count data. The day numbers along here. And this is the summer. And this correlates with the 24th of May to the 6th of September. You could choose another value, but it's interesting that it picks out the season. Some years, though, you get values totally out of context, out of season, but also big differences from one year to the next. So that's why sporadic E is such a variable feast. Early January looks quite good. This period in here, that I've highlighted in green, produced a lovely opening, 6th of October. So how good is that? Totally outside the normal season. But again, on FT8, it was doing a roaring trade. And I managed to work a couple of stations on CW on 6 meters as well, down into Italy. They also did a very nice piece of research to show you where sporadic E happens typically. And this is based on GPS satellite network and a very important study in terms of the climatology of where E's typically occurs. Amateurs are very good at finding out where these things happen. So using amateur data to try and fine tune all of those many factors I showed you, we've got this on our website now, which you can have a look at. And you put your postcode, you put your locator in, and it will plot 2 radial rings, typically half distance somewhere in here. And that will be the direction to go, looking for an ease patch. So it's not whether it will happen or not. It's if it happens, this is the direction that you want to go in. So this is what we covered earlier on.
Just to mention there, sorry, Jim, you said it's on the website now. Which website?
That's PropQuest, which I'm just about to come on to.
Sorry, okay.
And what you can do, there's a test version which we're using now, which is using 2 locators where you can put in the start, put in the end, and see where the half distance goes, and it's proving to be quite interesting. So there are examples coming forward now where we might be able to look at an event and put the details in and see where the ease is likely. Now, this is having an event reported on a cluster, but these charts are available each day for the next 24 hours. So you can see 12 hours before time and 12 hours after time, and you can move the slider and see where the intensity is, and it condenses all of that. So as a new operator, you've got a lot to worry about, a lot going on in your mind. Just look at that index during the ease season, and you'll see if you can piece together paths that come up with those. Rain scatter, loads of radars to have a look at if you're into the gigahertz bands, and you can use those. And then the other thing to use is PropQuest, which is this this website which a colleague of mine at work, Dan Holly, produced. He's done the programming work for me. He took pity on me, and he's done a really good job of this. So you get jet stream charts every day, so you can have a look at those. and every 6 hours, so you can see where the jet streams are going. You've got FOF2 indices, so you can see how NVIS conditions might work. The purple dots are FOEs, so you can see whether they're sporadic E. Sometimes you get very good examples of sporadic E, but remember, these are all in southern Britain or the near continent. You want something like this halfway between you and the DX, but it's great for seeing how things go. And when the band fades away, you know not to be on 14 megs after this point. You want to be coming down in frequency. So as a new licensee, just be prepared to have a look at this website now and again and see which bands are open and why they're changing. Because as the band fades, you'll find that the bands, these frequencies here, as the conditions fade, 7 megs will go out, and then perhaps 3.5 will go out. So the only thing that's left is once you've had your local into G net and you can't hear the other people in your radio club, all that you can hear that's left are the signals that are farther afield. And these distances along the bottom here are the skip distances for what's still there. So even though this one has gone below 5.2 megs, this one is still above it. So that means for a 1,000 kilometer path here, you could still have conditions, propagation. So this is the one to use, NVIS, and this is going to give you those 3 parameters that will determine whether you can have a local net. And then something just that's flagged up from this morning when I dug it out was that at the beginning of a sporadic E season, the paths tend to come up to a peak in the middle of the day, and in the high season, in the middle of it, they tend to have 2 peaks, one in the mid-morning and one in the late afternoon and early evening. Now, what I want to do is I want to just have a look at PropQuest now, and let's put that on here, and we can see, if I just refresh it, you can see here that the FOF2 at 5 is 5.1 megs, so we should be doing good trade at frequencies below that, providing there's not D-layer absorption.
So can I just say, Jim, because I'm not sure everybody at home can see the absolute detail on there. This is live now and for today, isn't it? Right now.
Yes, it's live. If it may be a bit clearer if I make it a bit smaller on the image. Can you?
Yeah. No, I'm sure that they might be able to. I just wanted to clarify that because there's a lot of information on that screen.
Propquest.co.uk on that tab there will tell you exactly where what the conditions are like in any one of these 3 stations. You just click on whichever ionosonde you want and refresh it, and it shows why earlier on today I was hearing signals coming through very strongly on 18 megs. Let's just see what's happening over here on
so that's your software-defined radio. Oh yeah.
And that's DL. That's DL. I think it was DL6WT. Now, let's have a look and see what the FOF2 is. The FOF2 is 5 megs, so we shouldn't be able to have a close-in QSO on 7 megs because the skip has now gone too long. It's below. See, here's the green line for 7 megs here, but we're hearing a DL who's probably going to be about 500, 600 kilometers away, which is why his signal stands out on the band as being really strong. And this is what you find when you listen to the band and look at one of these. You'll see when the conditions explain, if you like, why the conditions are changing. So let's find another one, see if we can see who this is. Oh, well, they all... I'm just giving a QSL 599. Let's see what else is going on. No, I don't think we're going to be lucky here. No, see this one. No, we're not going to be lucky. But what can happen is when you're on the band and you hear the band fading, you know, suddenly you're working a load of locals around G-land or in one of the RSGB 80 meter CC contests. Suddenly you can't hear many G stations and you only hear, say, the GM folk up in Scotland or Irish stations from EI land or Europeans, and the band goes long. It's because as you approach sunset, all these curves start to come down. Really fascinating. Learning how bands work by doing this. It gives you many years of SWM.
Can we see a close-up of that screen again, Jim? Make that bigger for us. Thank you. That's great. Yeah.
And the tooltip will allow you to hover over and see what the different frequency parameters are. But you can also have a look and compare another date. Yesterday we had a dropout, but let's do a compare. No, we can't do that because that was with the wrong day. Let's go back to the 8th, and you can see how one day compares to another, and you'll find all sorts of variations. So let's be really mischievous now, and let's go to February. And there are quite big differences between where we are in the red curve, which is today, of course, and February earlier on this year. You can see the ionization levels, the FOF2 was much lower at that point. So it's amazing what you can actually look at. The NVIS conditions you can see here as well. They're just coming down through 5 megs for the FOF2. FOEs did get up here to about 4 megs for a time, and then we had the averages, but this is the bit we want to show you. And this is going to be, it's just got to go off and get the data. I'm going to put my own locator in here. There we go, and let's see what we get. Have we got anything in there? Oh. No, it's coming in there. Is that going to come up with anything? Let's have a look. I think I've exceeded my bandwidth now on this one.
I tell you what, Jim, I must just say it does fit in really nice that you're doing this, because David M0VTG says, I rue the day when the telly stopped using real weather charts. I think you doing this for us will be as close as we're going to get.
Let's just see if I can persuade something to happen there. Anyway, you can see we've got something there on that. No. Let me just go to that one, go to that one, go to that one, and then do that. No. So let's try this one. No, don't seem to have any way of making that. No. Okay. Well, that does work because we've seen examples of it, and I think the point about it is that when you're actually trying to second guess what the band is doing by listening to the signals you're getting through on the speaker, by actually hearing what is happening, whether the band is going long skip, whether you were hearing signals on 18 megs or even 21 megs earlier on today, you can actually, by plotting these, see roughly how it went. Now, you've got to remember when you're learning how to use these, that these are over southern England and the near continent. So you have to allow for the sun, if you like, or the earth to turn a bit more, for the path to open up going across to the States, for example, and so on. But you've got your sunrise and sunset here, and you can see exactly how it changes during the period. It looks like a very flat curve, but it actually is. I'm just going to see if that works with a smaller size. No, it won't let me do that bit today. It was working earlier on, which is always the same with these things.
Just a moment then, if I may, Jim, just to remind everybody at home, this is getting near the final minutes now, really, of today. So if you have a question or a comment that you'd like to send straight to Jim Bacon G3YLA, this is the time to enter it on the YouTube chat line.
Right. Well, the idea is, I'll just do the final thing here and just say, when this system is working, and it was working earlier on this morning, so I can only assume there might be a few people sort of going into it at the moment, which is giving it a bit of a challenge. Let's just pop that up there. it'll be possible to put in over the winter. Dan and I will be working on this, and he's done a fantastic job with this. To be able to put in 2 postcodes, you'll be able to get the locator, the call sign, you'll type that in, you'll know which band it was, what the date was, what frequency and so on. And it will be your log of the path and how it worked.
And this is all free, Jim?
Yeah. PropQuest, I have to say, big thank you to WeatherQuest for sponsoring it on their server. And we've used the data feeds to power it. And Dan and I obviously worked for WeatherQuest, and until I retired, it was much easier to be in touch with it. But hopefully this will continue for a very long time to come, and it's the sort of thing which will port across to any server if it needs to. But
so again, once again, it's propquest.co.uk.
Yeah, it's propquest, propquest.co.uk. Okay. And if you go on there, and if, as I say, during the sporadic season particularly, if you click the EPI tab, you'll be able to see where the hotspots are, and you can see whether there's anything in the right range. At the moment, this is a test version here, but you can put your own single locator in. So whichever part of the country you're in, you come to this EPI page, put in your locator, and then it'll draw your radial wings, give you a big option, and we're eventually going to narrow that down so you can fine-tune it. But if you were looking at, say, why a station in Sweden was working someone in Ukraine, you could pick one end or the other from the DX maps.listing and put that in and see where the radial wings go, and you'll probably find one of these areas. Tends to be yellows is good enough for FT8, and at the moment this reddish hue is about right for CW or SSB, but only at the right time of the year. It tends to, I think it's only been running for about 4 weeks, so we're just feeling our way through it, and next year will be really useful. So all I'll say is enjoy exploring propagation, because it's interesting and it's what makes your hobby work, and try and use all these resources to build up that knowledge, which if you haven't, say, spent a long while as an SWL, don't be afraid of that. Don't worry about it, because there's a load of things you can find out about. And it's the one area where amateur radio can contribute to knowledge. If you work somebody, go onto the wonderful DX maps and the many other clusters, Make More Miles on BHF, ON4, KST, loads of them. Submit your logs and put your QSOs in, so the people who look at these things can study it and will eventually refine the algorithm. I know algorithms have not had a good press lately, but this one is under development, and we're kind of looking at ways to make all of those complicated things on the schematic sort of distill into just one simple map that you can use for.
It's like they say, isn't it? A picture's worth 1,000 words, Jim. Oh
gosh, yeah. It's such a joy to see it happening. I'm just disappointed in the real world we couldn't get a link. It's probably because I left the link open for a long while and it's binned me out on this machine.
All right. Well, it's great. We've got quite a few questions for you. Normally at this time we wouldn't have been allowed to go to quite this late, but of course you are the last speaker of the year, and I'm sure everybody at home will forgive us for overrunning slightly. So we're not going to lose any lines or anything like that. So these are the questions. Peter, GW4ZUA. I use aluminium poles to support my antennas. Highest is about 8 meters. Is there a safe height that won't attract lightning, do you know?
No, lightning, you're in the lap of the gods with lightning. You tend to find tall things are very good at attracting lightning, but there's no such thing as somewhere that isn't very good for being hit by lightning. The whole business of this is if there's a low resistance pathway through the air because of moisture or mixing of air mass and things like that, you'll find the lightning will want to find a way. You know, in the days you used to hear in the high summer when we had these very active thundery storms coming up from France, the French imports, very, very good thunderstorms in the sense that they're massively active, but they can carry a lot of lightning with them, the summer heat thunderstorms. And they have very high cloud bases, so you can see them from a long way away, but the lightning will find a path to Earth somehow or other. And you used to see tales in the news bulletins the day after of loads of cattle being killed in a field because of lightning. And that's probably because they were standing around their metal feeding bowsers where they put
So
over
they're
the
within a
head.
metre or so of the ground, so there is no safe height.
No, well, the other thing is that the problem is the cow's front legs and back legs are a long way apart. So the thing is, if lightning struck that metal railing, then there'd be however many tens of thousands of volts where it hits, and then as it spreads out through the earth, the resistance will mean that the voltage drops. So as you know from your REEs, when you do those, the voltage drop will mean a difference in voltage between one end and the other. And if you've got a difference in voltage between your front legs and your back legs, then that'll pass a current through. And that's why the animals, if they formed a ring around the feeding trough, they'd probably be all right because they're a bit more similar voltage. So when we're out there in the middle of a field and you're not a high point, you want to crouch down on one leg. I can't do that now. My knee would probably. But you don't want to make yourself the highest point.
I think the safe thing is just to keep out of the way if you've got that really.
Absolutely.
Olwyn G8DOH says, I often find nice tropo when Hepburn F5LEN shows no enhancement. Would you encourage people to use the most up-to-date surface pressure charts as well as the tropo prediction sites?
That's a really good point and fantastic presentation from you earlier on, Olwyn. That was really interesting, and a lot of thinking to be done there. but that point aside, the thing about those tropo prognostications are that they're defined by the vertical resolution in the mathematical model that's used to power them. So if it has a layer, think of the globe as represented by an onion with loads of different onion skins, and each one represents a layer of data in the mathematical world. And models can resolve better weather or resolve weather better if they've got lots of onion skins. So you've got more detail, more resolution in the vertical going up. Now, in the modern world, the tendency, well, when I was a Fortran programmer at Bracknell on their supercomputer back
that was
in
at the Met Office, I think, wasn't it?
Yes, in the Met Office.
Yeah.
The model then, one of the early models, had 10, it was a 10 level model, 10 layers in the vertical. These modern ones, as I said in the talk a minute or two ago, they're 70, 80, 90, over 100 levels in the vertical. They tend to concentrate the layers a lot where they're more important, like at the height of the jet stream and down near the surface, but they won't all have the same number of layers. And the other thing to bear in mind at the moment, it occurs to me, is you know how when aircraft go across the Atlantic and so on, they're measuring data, positional data, temperature, wind data, and so on, and moisture content and stuff. Now, the captain isn't taking his hand off the steering wheel and phoning up with the observation. What's happening is it's automatically being interrogated by satellite, and it goes back into the global network. So all these mathematical models get lots of data on very busy routes, a bit like in the old days ships would send weather data back to, and a lot of our good CW folk have no doubt done that in their careers in the Merchant Navy and the Royal Navy, been sending weather observations. And as ships became bigger, ships became fewer. So you don't get so many observations. So satellites were then used to fill in the gaps. Well, now, during lockdown and the lack of transport usage, I suspect that the mathematical models maybe are having occasions when they have a bit of a wobble because they haven't got the density of data along jet stream paths where that can be quite important. So it's all about how many layers in the vertical these models have. They will be different. They won't have enough to properly represent these surface inversions. I'm just trying to think. You know that picture I had at the beginning of where we had the picture of the Welsh Valley with the fog in the bottom of the valley. I don't think the models will know much about that necessarily. Some of them will, some of them may not. And therefore, it's quite possible that you could get, tropo appearing through one of those situations that doesn't appear in the prediction charts. I know when I went to see very nice folk down at the Blackwood Amateur Radio Club. This was back in the 80s, I think. And they told me of this is South Wales, for those of you who don't know where it is, South Wales valleys, VHF conditions in the bottom of a South Wales mining valley, virtually nil, except up and down the valley, because the steep sides for VHF aren't good. But in the summer, when the sea breeze comes, it brings in cool, moist sea air up the valley and forms a perfect tropoduct, such that the GWs in South Wales would use that to work down past Cornwall to northern Spain. And they'd have tropo down to northern Spain, but just when the sea breeze coupled this waveguide up the valley. So these local, very shallow things can be important. Even walking up the cliff path at Folkestone or somewhere, or where on the south coast or on the east coast at Lowestoft or somewhere, just going up and down the cliff will alter your propagation chances of going across the North Sea into PA0 and so on.
Mike G4 CDF says, do you have any comment on how to understand conditions for troposcatter?
No, I'm not a troposcatter person at all. We've got one amateur up this way in northeast Norfolk who I think did a talk either last year or the previous year's convention at Milton Keynes. But troposcatter is a very good mode to use if you're into power and weak signals and presumably integrating over long periods of time and all the rest of it. But I'm not an expert at all on that. Everything will scatter. It's just a matter of how much you throw at it and how much you get back, I guess.
Okay. I've got Chris G4IIX in York. This is a great question. What's the approximate weight of a large anvil thunderstorm cloud?
That is such a good question. I'll have to park that and go and find out.
It reminds me when you were on Eggheads a few years ago, wasn't it? It's the sort of question that would have come up there, I reckon.
Well, it is kind of like that. But let's just start with one thing. You can get many tons of water aloft in a thundercloud. So if you think in the middle of a big supercell sort of cumulonimbus cloud, there's vertical air currents going up at over 100 miles an hour. Now, if you put a tank of water up there, it wouldn't be able to hold the tank of water, it crash down. But if the water is in droplets, then a 100-mile-an-hour wind can easily keep loads of droplets up there, which is why in these big shower clouds, so showers produce heavier rain. It's not by accident they produce heavier in terms of intensity of rain, may not last as long, but it's more intense, is because the upcurrents can hold bigger droplets of water in suspension before they come down again. So the answer is it'll be many, many hundreds of tons, I would think, in terms of the water contained within the cloud.
Okay, so it's a rough estimate, but there's a lot. Now, as several people have said, is there a book available on the subject you're talking about with radio with weather? And before you had a chance to answer that, our mutual friend at the RSGB HQ, Mark Algar, has said that Jim has said, you know what he's going to say, don't you? Jim has said, when I can send the shipping forecast on CW, he will finish the book. Be careful what you wish for, Jim.
Well, no, I'd gladly do that with that deal. I don't know how the Morse is coming on, Mark, but hopefully it's doing all right. It's got quite a lot of complicated text in it, the shipping forecast. But no, I have started. Tell Mark I have started it, and now I've retired pretty much. This is my job during the next year. Is to I've nearly finished getting the shack in order.
We're all the same, really. We just tidied this up for the day.
The only thing good to be said about the construction bench is that it is a construction bench because I made it, but I haven't actually cleared the rubbish off it yet to actually do any construction. Anyway, point is, the shack is nearly done, and I've started writing the book and putting headings and done 1 or 2 paragraphs. So it has been started, Mark, which is a better sign than all of the last 10 years of you badgering me at the real proper
You
convention.
keep him up to that promise of he's going to send you the shipping forecast in CW, won't you?
Yeah, you've got to actually send it to me over the air, though. I mean, that's got to be...
I've got several comments. I mean, lots of comments saying they love the talk, and there's a few here. Ian M7IGN says, this is a terrific session. Thank you, Jim, for translating jargon for we beginners and for taking a technical topic and turning it into something easy to understand. It's useful and encouraging. And he also adds, it's the first time he's understood sporadic E.
Excellent. Well, the best thing you can possibly do And there's one, and I forgot to say it in the talk. I don't know why, because it's the one thing that I say when I trot around the place doing this talk about sporadic E. During the summer months, and by that I mean the peak of the season. I don't want you wasting too much time doing it when there's Tropo to be playing with and CW and things like that. So in the months of May through to the end of August, if when you get home, if you're still working, but if you're not, you can do it anytime. But if you're at work and you say, I haven't got time for sporadic E, if the first thing you do when you get home from work is switch on 6 meters, 10 meters, or 2 meters, or 4 meters, and look for sporadic E before you have your evening meal, you will, I guarantee you, work lots of sporadic E in your very first year.
So it's tea time, actually at tea time.
Yeah, well, it's a generic sort of anything from about 5 o'clock in the evening till about 8 o'clock in the evening in high summer. The chances are you will hear people talking of sporadic E or be able to hear some yourself. And if instead of saying, right, I've got home from work, I'll just cut the lawn before I have my tea, don't. Go in there, put the rig on, do that, and the lawn will still be there.
All right. We've got Essex Hams now. They do. So I know you know Essex Hams. They do great jobs at training people online, which has been so important in these COVID times. And they've got a couple of questions. Sporadic E for newcomers. What is the average duration of a lift condition?
Okay. Well, an opening can last for 2 or 3 hours, but it's not usually to the same station. So when it's a really strong opening, you might hear one station working a few people, and you might hear him working or her working maybe a dozen other signals. And then that one will fade and another one will pop up. And the one thing I would say is that SDR radios, like I showed you on the screen a while back, are just the greatest way of dealing with sporadic E, because some of them you can have multiple slices. So the flex, particularly, you can have you could have transverters, and you could have a look at 10 meters, 6 meters, 4 meters, and 2 meters.
Yeah.
If you've got them all kitted up. But even just 10 meters and 6 meters, you can see how the openings are moving from 10 meters. That's the other thing. Sporadic E starts on the lower frequency bands and works upwards. Don't be surprised if you hear, well, people don't talk about this very often, but they should. Sporadic E affects paths on 80 meters. You can have lots of good local CW nets on 80 meters, and sporadic E will help you when those graphs that I showed you, the FOF2 graphs and these, have gone below the band that you're on, below 3.5 megs. You'll be getting 5 and 9 plus signals from your mates up the road. And that's because of sporadic E on 80 meters. But the sort of stuff we're normally talking about is not this NVIS stuff locally, but this single hop, which tends to be to about, I don't know, 1,000 kilometers out to 2,400 at the extreme end, and that sort of range. Really strong signals, and yeah, you'll definitely work it in your first year if you just listen at tea time instead of cutting along.
Second part of that question from Pete M0PSX from Essex Hams is any good websites for newcomers for lift condition alerts and predictions? Is there any specific sites for that?
Well, during the summer months on let me just I'm just going to go back to my screen here for PropQuest. If I go back to this, and if I do this, in the summer months, I write a blog here every single day from the 1st of May to the end of August. And that blog talks about where the jet streams are and where they're likely to be most productive. So it's a heads up, if you like.
So head off to propquest.co.uk, really?
Yeah. And this one, when it contains the data, it looks like the model didn't come in today to do this, so that's obviously not good. I can't.
That's okay, Jim. That's given them a great deal of help. Another, the second and last question from Essex Ham. Another question we get from newcomers: how much of a risk is lightning to a shack? Is it old wives' tales? Should we really unplug our antennas and put them in a mug? Any protection advice from you as a weatherman?
Well, I mean, the thing is, over the years, I've never really done anything specific myself. That's not a recommendation to say do as I do. I will occasionally switch the antenna changeover switch to dummy load, so the rigs aren't connected. unless you're going to go around and unplug literally everything. If it strikes the house, it'll be through the mains and through the equipment and so on. Aerials are out there. You can't lower them every time a storm passes by. I've had storms logged on here within a mile away from me and haven't caused any damage. But there's always going to be one time when it does.
So not old wives' tales, really. Just do take precautions.
Well, don't sit there with headphones on in a thunderstorm.
Yeah.
You know, I mean, there are common sense things you can do. I know we tried to see Roger off in the last year's NFD when we sat him in the tent in a thunderstorm. But I think realistically, you just need to have your wits about you. If there's a storm nearby on any NFD or special event station, things like that, don't put yourselves and your fellow operators at risk by ploughing on operating through a thunderstorm. There's nothing wrong in saying QRX, we've got a thunderstorm nearby, we'll be back on in 30 minutes. And you can use the radar on the phone apps and things, WQ radar, Blitzorg, loads of them out there, and they will tell you when the storm's moving away. So just be sensible about it. Don't take unnecessary risks. To be honest, sitting in a car, if you're out on a field day site, sitting in a car is actually not a bad thing to do either, because you're in a Faraday cage, and providing you stay in that while the storm comes past, you're probably going to be as good as anything.
Okay, Essex Ham's up. I know you'll share with me the wonder and the wonderful news here. Essex Ham sent a message to a Thomas W who's watching, and he asked him how he got on with his foundation course today. His exam, and he passed, which is fantastic.
Excellent.
So congratulations.
Well,
yeah, absolutely. Congratulations from Jim and me and everybody here at the RSGB convention, Thomas. So we look forward to hearing from you and hearing you on the air as well. What else have we got here for you? Some of these are obviously messages for other people there. Good job, folks. Also explains why hearing good signs on 17 metres at 2 p.m. in Derbyshire on indoor home brew with a £5 mag loop.
Excellent. Yeah, you see, it's right there on that screen, isn't it? If you look at the 3,000 kilometre F2 muff, it was 24 megs, so it nearly got up to the other watt band, pretty much. So yeah, it's a great thing, and you can see the transition during the day. And if you go over here to the left, I don't know if it's on the screen.
Yeah, we can pop that back on the screen, Jim.
Yeah, so here's the peak during today up here, when at about 12:30 or so it got to. Bearing in mind this is a middle of the day thing in Europe, so if you're waiting for the States to come on board, that's going to be this afternoon while we're talking and so on. But the point is, you can see when it changes, and especially if you're doing these contests like CQ Worldwides and the RSGB, DX contests and all those, you can see when the game is up, when it's gone below a certain band, and you can use this to plan your when you look at the averages, which we did before. So let's do an average for June, which is when HF CWNFD is. You can see how it varies through the 24 hours, and you can see what the FOEs is like and things like that. There's all sorts of interesting things you can do.
I know, it's wonderful, Jim, and thank you ever so much for sharing that. And indeed, thank you very much for your talk, because we have run out of time now. We're really grateful for you, not only for the talk you gave the other stream, learning more about this morning, but also for this talk which you came in at the last moment to do for us. We're really grateful, and I paraphrase everybody who's put comments on here. It's great to have someone like yourself who can explain this in terms which we can all understand, and we certainly now know why weather and radio are related. Jim Bacon, G3YLA, thank you very much.
It's been a pleasure. Thanks for all your questions.